Hi, Matt. Welcome again to the Nexus. Thank you for being here.
Hey, Marc, thank you for having me back.
Of course. Well, it's a pleasure and an honor. For those who didn't see our first podcast, just a brief introduction, although I think many people, or most people here will actually know Matthew. So Matt is a generalist. As I introduced it last time, that makes him a dying breed. I mean, it's the way I introduce you. If you have anything more to say, do so. But what I mean with generalist is that Matt has prolifically written from politics over science, epistemology, humanity in the broader sense, and so on. And as far as I know, which I failed to say last time, I think you're also a fellow at the University of Moscow, whatever that means. What does that mean?
It's it's the American University in Moscow,
Okay.
and it was supposed to be an official university set up in the 1990s, led by a nuclear physicist, Dr. Edward Lazansky, who's a good friend of mine, and it didn't work out. A lot of backstabbing, and I think the neocons on the other side of the Iron Curtain had a different idea for what Russia was supposed to be than what Ed had in mind. So they left it with it basically ended up as a building with no faculty,
Oh.
and a nonprofit organization that Ed has been using for the past 25 years to promote peace between U.S. and Russia, economic bridge building for, in Washington and other things. So it's more of a think tank, educational platform, but not an official university, unfortunately, yet.
Well, something that is building peace between the U.S. and Russia would deserve more than a building, you know?
Yeah.
All right. So let me introduce today's topic. When we first talked with Matt, that was an offline meeting, and we discovered that we had a difference, I guess, in epistemology, which is a difference in the way we view the world. And so that very quickly seemed to go towards a debate, which I personally love debates. So let me set the stage for that, and let me begin by saying that I believe we share lots of our core values. Like, we both want to see a better world. We both want to see and promote meaningful, happy life, or meaningful more than happy, I guess, if you want to look into the details. We see virtue. We view humanity as a force for good. It's not like one of those very popular ideologies nowadays, which are along the lines of, yeah, if humanity died out, it will be better for the universe and for the planet and all that sort of thing. And so we also see the potential that is there for humanity for a virtually infinite growth. And I say virtually here, but picking my words very carefully, because I think this will be one of our points of contention. And so since debates have a tendency to go off topic, it's important, I guess, to set the stage. And so I will just briefly say about myself, I consider myself a hardcore rationalist, materialist who aspires to get some, I guess, spirituality. And I've tried different paths, which maybe at the end we can go into if we have some time. But I just am having a hard time finding spirituality in the classical sense. And when I say materialist, there is much more behind the word. No, there's much more behind the materialist view that usually people give it credit for. And I think you also tend to view materialist as a very restrictive, overwhelming power, but we'll get into that. And I believe you are you propose more of a spiritual, holistic view of the universe centered around, I believe, open and closed systems. And so what I suggest is the structure as follows, which, if you can give us a brief digest, like maybe 2 to 5 minutes of what you consider your epistemology or worldview to be like, because I wrote different paragraphs of how to summarize open and closed systems, or the view that I got from Science Unshackled, which is your book, which everyone, by the way, should tune into, look into. And then I suggest that I will proceed by laying out my argument. I mean, there's several, but I guess I focus on one, which is an argument that would go, I guess, against the general tendency to build a universal worldview, like a worldview of nature, in a spiritualistic or maybe esoteric, I don't know how to call these. Let's call them spiritualistic or esoteric alternative sciences, centered on what I would like to call intuitive reasoning. As I said, there's a multi-pronged argument, but I will center on this one thing, which is intuitive reasoning. I will give key examples from physics, and then I will finalize my argument by proceeding a proposal of how one could actually build up an alternative science. And in particular, I propose an idea of how to reconcile, I guess, what I took might be your core views about, infinite growth of humanity and all these open systems, with my hardcore, cold, modern science materialism. And then, so I will probably need 10 to 15 minutes for that, and then you get to rebuke, and I guess we'll take it from there. Does that make sense?
Sure. So you want me to do a little 2-3 minute
yes, please.
Summary of my general way of thinking about this, and then you're going to do a broader elaboration on your views, as you just said, of what a healthier approach or higher synthesis to science would be, and then I'm going to respond. Okay, yeah, sure, all right. Yeah, this is fun. A cool little exercise. Yeah. So okay, there. Well, first of all, yeah, I guess the book you're referring to, just so people could see it, it's Science Unshackled, Restoring Causality in a World of Chaos, that I just published. Huh?
Beautiful cover, by the way, yeah.
Yeah, it's a little statue in Montreal. My wife took the picture, featuring an angel breaking shackles. And actually below the angel, it actually says Ciencia, which is a nice little imagery there. So yeah, the idea of science that I'm attempting in my limited way to make transparent within the course of about the 11 or 12 chapters within the book is that we have been told a sort of narrative about the story and the history of science, what it is, how it works, how we're supposed to think of this concept, and use our mind in accord with certain rules of best practice when we're doing science. And we're told this thing that there's this thing called Western science, Western philosophy, that has a continual expression going back to the Greeks, and we're given a narrative of certain major players that made important advances. And it's very apolitical as an analysis of this model of scientific history. Based on my research and my experience in politics and in organizing with the Schiller Institute and just trying to make a better sense of what is the causal agency behind a lot of the wars, the assassinations, the ability to overcome limits to growth and refute the argumentation that has always been maintained by an oligarchical class of wannabe masters lording over slaves, that we have to live within our limits, live small, live with less, just adapt to whatever exists at the current moment. This is a futile line of argumentation, which has an agenda or a way of thinking and defining human beings that is dishonest, that actually is designed to create a mental wall around what is possible within us, such that we're happy just being little, being subservient. And when I approach history, and this agency is very important to keep this in mind as an important factor behind the assassination of many world leaders throughout the years. Many scientists have been also assassinated over the years. Many wars have been initiated by this thing, and in a polite society we would say, oh, that's just they would dismiss this whole line of argumentation that I'm talking about as being conspiracy theorizing. But I'm maintaining that that's the only competent way of looking at history is from the standpoint of conspiracies, for good or for bad. But within that context, I've come to recognize increasingly that there's two, not one, but two fundamentally different continuous schools of thought defining science and philosophy that is oversimplified as one thing, Western philosophy, Western science. And so there's a political battle shaping it, and I tried to get across some of that going back to the ancient battles between Plato and his school, his academy, and the Aristotelian school, and also the Neoplatonist mystics and Hermeticists as well, who tried to redefine and co-opt what science was, where only one school is being potent, is actually making discoveries by recognizing that there is a fundamental what one could call in modern terms like psychophysical parallelism, that what is going on inside the minds intellectually
I see. I see.
has a resonance in the external physical world,
This is what I
and that
call
when you make,
spiritual theory.
yeah, I guess you can. There's so many labels there that people call this property that has been explored for a long time, but that when we learn how to lawfully overcome the limits of our ignorance, we are given powers in the physical world, capabilities to do things that involve utilizing or creating, inventing new technologies, new types of ways of organizing ourselves, both socially, but also in the form of scientific technologies that allows us to sustain more of our people at a higher quality of life with greater access to our mental powers. And that play back and forth is something that I see as fundamental to the entirety of the universe. I see it as a universal power, although there are always boundary conditions.
Mm-hmm.
And so what you were saying about my thesis, and I'll close it up here because I know it's about 3 minutes I've been talking. The idea of the interplay between closed versus open systems, I see it expressed most clearly in that way, that the system of the what defines the limits of any system, what are the mechanisms, are something which we could either treat as absolute, as some do today, who wish for us to presume absolute limits to the universe, to the solar system, to the human systems, to the ecosystems that are always running down because of their absolute limits that they assume in space and time, that there is only, the more you have activity in any system, the more it is draining away energy for the whole system to function, and thus creating an accelerated entropy within the second law of thermodynamics. I don't think that is that idea of the absolute limits is in any way a truthful universal, but simply a relative contingent of something higher. And that higher thing is this yearning, this capability of creating new energy, new power that didn't exist in the previous system, and is expressed in most clearly in the human domain, although it is also viewable within the biological domain in evolutionary time, or even in perhaps the abiotic domain of non-living matter as well, in longer space-time continuums. So that's how I'm sort of approaching my open versus closed system, and my definition of the healthier versus unhealthier toxic branches of so-called scientific traditions.
All right, thank you. That's better than I could ever have put it. I would have not done it justice.
Okay.
So before I proceed with the agreement and then my disagreement, I just wanted to add one more little note of vocabulary. First, I tend to call it epistemology. You referenced those ways of thinking before by schools of thought. To me, that's the same thing, just so we're on the same page. When I say epistemology, it's the way of...
Yeah.
Then you mentioned something psychophysical. As I said, call that like a psychophysical theory of nature. I would tend, I don't know how to call it. Otherwise, I call it spiritualistic or holistic. Okay, so just this will be my terminology.
I don't mind ambiguity. Ambiguity in language is fine. I don't think we'll ever overcome it. I'm not into Esperanto.
So next up, I just wanted to say something about debates, just before I jump into it. So I love debate. I can get very, very fervent, probably not today because I'm not perfectly well slept. But I have been told that I do not use the most diplomatic language, because when I go into debate, I just want to treat the topic. I don't want to sugarcoat or like formulate it otherwise. I never insult. I will never attack you personally. I will never take you not seriously. But I might not sugarcoat or be like emotional intelligence during a debate, right?
Yeah.
Then I might also push analogies all the way to hyperbole to make a point more salient, just as a little forewarning. And to me, I just love debating, and I think just intellectual honesty is at the forefront. And I will also, if we get to it, I also like strongmanning. Are you familiar with that? It's the opposite of strawmanning. It's where you say something, and then I have to repeat what you said in the best, most favorable, strongest possible formulation with my own words, and then you say whether I captured it right or not. You know, that's just a good practice. Anyways, let me start with my agreement. So first of all, I read at least the four last chapters of Science Unshackled as per our mail exchange. I think I also delved into the other stuff you sent me, but it's been a couple of weeks. But I do have plenty of notes and so on. In any case, let me start with the part where I agree. So first of all, I found it fascinating, and it's in many places a sharp critique of of science, which I'm absolutely on the same page as you. And one of the things you mentioned in there is dogma. And this is one of the places where I most fervently agree, I guess. And one first thing I want to mention is that we have to differentiate between science as an epistemology, which is the scientific method, which is just the way of thinking, and then science as an institution. And science as an institution is political, corrupt, dogmatic, as not as any other, but almost as, you know, ideological as any other. And I actually, to underline my agreement, I had a few other examples of dogma from science, which I didn't see in your book, but which are very famous in science. Heliocentrism. It was heretical in the beginning. People were burnt at the stake for it. The tectonic plate from Alfred Wegener was considered heretical in the beginning. You know, it's absurd how huge continents moving around just doesn't make sense, but it does make sense. Then, I don't know, the germ theory was considered heretical, Darwin's theory, quantum mechanics, and so on. There's plenty of examples where a new theory had to push against the dogma of the old ones. One last point about the agreement. You talk about the absolute limits to growth, and there is, from a scientific point of view, like I haven't said it, but I think many people will know, I'm a physicist. From a scientific point of view, yes, there are close to absolute limits to growth, but we also know that we don't know anything, and we also know that science is open-ended. For example, what kind of questions did people in the 14th century ask about radioactivity? None, because they didn't even have the idea, the concept of it. So this new discovery of radioactivity opens an infinite number of questions about radioactivity, which is to say that every new discovery opens up more questions than it answers in science. So science will inherently always be infinitely open-ended, and therefore we cannot ever say with absolute certainty that limits to growth are absolute. Like in this little 10 cubic centimeter volume, 96% of the universe is dark matter. We don't even know what that is, let alone what we'll discover in 200 years. So yeah, I can't really say with science that this is limited. Okay, just a little aparté. Now to the part where I have a difference of opinion. And as I said, I will center on this thing that I call intuitive reasoning. And to begin with, I want to talk about intuition. And I talked with a friend today, so to me, intuition will, maybe you'll have a different idea of what the word intuition means. If that's the case, just interrupt me and we'll see. And in my pushback, I want to start with an analogy with our senses. So what we see is just this tiny little gap between 400 and 800 nanometers, right, of the EM spectrum. We don't see infrared. We don't see microwave, we don't see radio, we can't smell ultraviolets, we can't smell X-rays, gamma, and so on. And in the very same way that our senses perceive just a teeny tiny band of what there is out there, in the very same way our intuition is only tuned to a very tiny fraction of the reality. That is, my intuition works well in events that are on the order of a meter or centimeter, that are on the order of second to an hour maybe, or maybe in interpersonal relationships of up to 100 people, right? My intuition fails as soon as I get down to the nanosecond, to the billions of years, or to, you know, light years in space and so on. And what I want to say with that is that, well, one example of how the intuition works well is I can catch a flying ball easily without having to solve the differential equations, right? And what I want to say with that is that intuitive reasoning, which I'll come to in a second, what I mean with that, is kind of like the theory of gravity of Newton. It works well. We can apply it in almost everyday life all the time. However, at some point we get to sufficient complexity and then we have to use general relativity. Otherwise we compute, for example, the orbits and the trajectories of satellites wrongly, right? All right, I will come. So this is about intuition. It's similar to our senses. It works well, but in a very narrow range. And there's this thing called intuitive reasoning, which, just bear with me for a second. I will get to it in a second. I just want to make one more point about language. Language shapes our thinking and vice versa. And we humans, we tend to anthropomorphize everything. We say that the cells that want to merge, the cells want to duplicate, two planets attract each other, pull on each other, and so we have this vocabulary that deals in agents. However, to the best of our knowledge, nature does not work in agents. these two stones do not really have agency. Nature works in processes. And so rather than the human language, we have learned over the, if we have learned anything from science, is that it seems, in fact, that math is the language of nature. And I have to give an example for that. For example, Dirac, when he derived his famous equation in 1928, he used something called complex analysis, which is imaginary numbers, and imaginary numbers flow from the root of -1. The square root of -1, which already, physically speaking, is an absurdity, right? This will be intuitive reasoning would say you cannot have the square of a negative number, right? Because you cannot have a negative surface. It doesn't make sense. That's a square, right? The square is a surface. Okay, so this is first little nugget. When Dirac solved his equations for Fermi, I think it was for fermions in 1928, he had a solution, and he had the matching imaginary solution, which at first glance is just an artifact of the tool, which is mathematics, that he used. And this second solution, which was seemingly just an artifact, was the same thing, just had different charge. And lo and behold, he hypothesized, okay, maybe there's something called antimatter, which is the same thing, just with opposite charge. And lo and behold, 40 years later, we measure antimatter. So here we have a very strong indication that this tool is not just a tool, it's actually way more fundamental, because it actually mirrors nature much more than anything else that we have. Similar examples can be given with what I talked before about infrared and microwaves. The Maxwell equations and electromagnetic waves. The waves are just artifacts of the maths used from Maxwell. The same holds for general relativity. Black holes are just mathematical artifacts, and yet we observe them. Gravitational waves are just artifacts from the equation. So to all intents and purposes, math is the language of nature. Okay, I'm getting to the intuitive reasoning part now. So after I established these previous things, I want to get into several claims of what I mean with intuitive reasoning. Intuitive reasoning is this classical reasoning which we know from philosophers. And intuitive reasoning will give us statements such as one thing cannot be two different things simultaneously. It has to be one or the other. Intuitive reasoning will also tell us, for example, one cannot get something out of nothing. Intuitive reasoning will tell us reality is absolute. Like if a thing exists, it either exists totally or it doesn't. Causality is absolute, such as you cannot have the result happening before the cause. And finally, and here's the fun part, which gets back to your book, intuitive reasoning will say the whole cannot be more than the sum of its parts, right? Okay, and here's the part where I want to go against intuitive reasoning. One famous experiment in physics, I'm sure you're familiar with it, but I'm going to sketch it out for the listeners anyways. It's a double slit experiment where you have two slits that are tiny, the size on the order of the wavelength of the electron, and then you shoot individual electrons through these two double slits, and then you have a screen behind the slits, and you measure the electrons there. And what you measure is individual particles on the screen, like you see dots, right? However, those dots that don't come in the form of two shadows, those dots come in the form of an interference pattern. The very same interference pattern you would get if the electron was a wave. And so one would say, okay, you shoot multiple electrons. We know from quantum mechanics there might be a wave, so they interact with one another. That's not the case. You shoot them one by one. So the individual electron waves interact with one another. The electron interferes with itself as it goes through the slits, and then is a particle at the end of the screen. So to all intents and purposes, as we saw, math is the language of nature. The electron is both a wave and an electron, something which intuitive reasoning would not allow for. You cannot be two things at once that are incompatible. There's plenty of other examples. One other example would be from general relativity. Simple example is we have Matthew on the field throwing a tennis ball. We have Matthew, a clone, on the train throwing a tennis ball with, say, the same speed. And obviously, the ball in the train will be faster because the train also moves forward than the ball on the field, right? And now comes Einstein and says, if that ball is a photon, then they move at the same speed, regardless of whether one already is in the train that's moving or one is just standing in the field. Again, intuitive reasoning cannot make sense of that. You cannot have two things that are the same speed even though one is accelerating the train and the other one isn't. And then the solution is complicated, manifold, warping, space-time, and so on. But this is another thing where intuitive reasoning just fails. And finally, to finish off with intuitive reasoning, my master thesis dealt with the holographic principles. And some of the models I had in there had not one, but 2 time dimensions. It's kind of mind-blowing stuff. And so when you say before, what do you mean? Along which of the time axes will you want to say before? How does causality work if you have 2 time axes? Again, something which intuitive reasoning has no room for, but logic and physics definitely does. Okay, I will finish off, if you're still with me, I'll finish off with, I have how we cannot start an alternative science and how we could actually do it. Oh, and then the reconciliation part. So if you want to start an alternative science, and I've seen debates, for example, with Dinesh D'Souza or Sadhguru and many other big thinkers that tend to have these, also these human-centered, spiritualistic or psychophysical theories. And they tend to have, I will use a strong word, a lot of fallacies. I'm not saying you do, but here is how they tend to do it and how it doesn't work. Anchoring it in humanity. For example, taking our consciousness, emotions, or free will and projecting it onto the universe as if these were the underlying mechanisms from which universe works. For example, the lion eats the antelope, and that's bad, and because it's bad, it cannot be true. And here is one where I will, I guess, shoot one at you. For example, saying the universe is a death cult, therefore it cannot be true, is another idea like that, where you take human emotions or morality and you project it onto the universe. Another part, another facet of this would be appealing to intuition. For example, I felt this, I don't know, sign of God or something so strongly that I have to believe in it. Yeah, you can believe in it, but that does not give anyone license to project it onto the universe and nature itself, right? 2, by appealing to fallacious logic. For example, the anthropic principle. Are you familiar with that one?
The what?
Anthropic principle.
Oh, to project humanity onto everything, the whole universe? Is that what you're saying?
No, this is a different one. This is basically the universe can only function the way it is by virtue of very finely tuned physical constants, and really, really finely tuned, like 10 to the minus 100 or something, finely tuned. If you change those very slightly, like, I don't know, the charge of the electron, for example, the strength of the strong interaction force, life would no longer be possible in the way it is now. And so people like, I believe Dinesh D'Souza used this one, people say, you see, God made the constants like this in order to facilitate human life. So it's basically inverting logic. Instead of saying, well, the way carbon life works now is because of the constants happen to be like this, he inverts it and says, they are like this in order to facilitate life, right? That's what I mean with fallacious logic, by inverting the principles. So,
okay, so it doesn't mean, it's not a reference to human. When I heard anthro,
it's called the anthropic principle.
Strange. Okay. All right. Well, I get the idea. I get the concept. So
yeah. Okay. So 3, third part of how we cannot start an alternative science. How it will be fallacious is by assuming deontology, which is by assuming the universe has an inherent meaning axiomatically, because that's just cheating, right? Because you just assume you're right axiomatically. If you add an additional assumption, additional axiom, such as the universe has a meaning and not just human life has meaning, because those are 2 wildly distinct things, then you have to prove why you take an ad hoc axiom on board. 4, by showing where science fails, say, I don't know, science does not explain emotions, then triumphantly smuggle in Jesus through the back door and say this is where religion, Christianity, or whatever, I don't know, fills the gap. And 5, how we cannot start an alternative science is by drawing loose connections between ill-defined, vague concepts like harmony, justice, virtue, or wisdom from, I don't know, Confucius or Plato, and linking them to new age concepts like quantum mechanics, just because quantum mechanics happens to use waves and harmony applies to waves. And now how we can actually build an alternative science, and this is just 3 points. 1, we could create an experiment. For example, we can test telepathic communication. By the way, there are some very fascinating experiments with the FBI and Uri Geller back in the day, and they had some very interesting results. So I'm very open to that. And for example, this experiment could also see whether the laws of nature change if there's intense feeling. For example, okay, this sounds cruel. This is one of the places where I push an analogy into the extreme just to make a point. For example, we could push a toddler off from a high-rise building and see if, while the whole world is watching, if, I don't know, their prayers or feeling of shock or the screaming of their parents or the emotions will make the laws of nature change in such a way that gravity stops just before the toddler hits impact and somehow survives, right? That would be an experiment. Or you can also construct some sort of ritual and see if that has any effect on the universe, on nature, right?
I hope no one's tried this experiment out already, throwing the toddler off the building. Have they done that?
I very much hope not.
Okay.
Yeah, again, I might sound facetious. I don't mean it facetious. I just want to push it, push the toddler. No, push the point across. So the second way we can do it is if we can find a law of nature where in the equation it's not just mass or energy or velocity, but if we have something like life, meaning, love, creativity as part of the law of nature, right? For example, if one can find a Schrödinger or Einstein equation that doesn't just have mass, but also love or creativity, or one of these concepts that you want to bring into nature as a fundamental of nature, right? And 3, if we can build an alternative science that successfully predicts things, for example, if we can find a psychophysical or spiritual theory that can build transistors and quantum mechanics and phones and flying planes and general relativity and satellites and so on, definitely we can build something. And I want to just add here, I'm very much aware that science does not tend to fund these theories, and so that we might have a big blind spot there. Now, just to finish up, thank you for listening. Just to reconcile what I think is your view and my view, I think the first step would be akin to Eastern wisdom, which is acceptance. You know, this whole Buddhistic and probably even older wisdom of accept the way things are, accept the evil spirit. I think the evil spirit was called Mara, and you might gain some wisdom. And I think one way is to accept that nature just does not conform to our human values, intuitions, and perceptions. And that's actually very freeing in a way. It's very nihilistic at first glance, but then very freeing at second. The second one would be separate science from institutions, because institutions are definitely, corrupt. And there was also something which I'll have a hard time putting into words, which is that it seems that the spiritual theories tend to converge on the natural, like tend to try to anchor at quantum mechanics, maybe at modern neuroscience and so on, while the materialistic worldview sees more and more of the spiritual. For example, we learn more and more about psychosomatic ailments, about how our way of mind can influence others in our own health and our gut biome and our immune system and so on. And so I think these two are actually in a way converging on one another. But that was my main argument, centered around what I call intuitive reasoning. And I don't know. Let me know what you think of it.
No, it's fun. I took a few notes as well. I guess for clarity's sake, when you brought up time moving in 2 vectors, I'm okay with that. But can I ask you to elaborate very, very briefly an example of what you mean?
With time can move in 2 axes?
Yeah.
So what I was dealing with are called anti-de Sitter spaces. And this is the holographic theory. Long story short, the theory says that the content of a volume, let's say a sphere, is inscribed on its surface. So in essence, I can compute the gravity theory inside the ball and equivocate it with the conformal field theory, just a flavor of quantum field theory, on the surface, which is very surprising because on the interior we have, say, n+1 dimensions, while the surface is just n-dimensional, it's just one less dimension, right? So how can the information content on the surface match that one of the volume? It doesn't seem to, again, intuitive reasoning would say that's impossible. And about the 2 time dimensions, it's a mathematical model. It's just when you write the Einstein equations, there are 2 dimensions that are time-like. You know, you have this 4-dimensional usual Minkowski space from Einstein, and I just had 2 of them in one of the models.
Okay. I'm going to give you an example of how I've also been thinking about it in a slightly more simple way, not so mathematized necessarily, but I guess it could have mathematical representation regarding the future and the past concepts.
Okay.
You know, since ancient times, there's been this concept of chronos and kairos, right? So chronos is the concept of time in Greece, of the unfolding duration where things have beginning, end, and change. Whereas kairos is sort of the higher concept of eternity, simultaneity of all things like that. So you got a little bit more of a top-down, bottom-up concept of time, but the Greeks just had a much more sophisticated way of thinking than I think a lot of us do today. So they a lot of their words that they use, where we have one word, they have 2, 3, 4, 5, 6 words. Kind of like the Inuit have, you know, like 12 different words for snow. So the idea of the, you know, we're sort of, when asked the question, well, what is causing this little interaction between you and me? And one could say, well, it was you the other day asking me to be on a debate. So you could say it's something in the past, you know, or what's causing this? So you could say it's the motion of what you said in the past just now is causing me to like have a response right now that I'm choosing. But at the same time, we could say it's the future, right? Like it's the future point that is not yet manifested, that is shaping the unfolding of the choices that we're making, both of us, in terms of composing our sentences, choosing, like, you know, what questions emerge. There's ultimately, we both have a goal, a point. It's not a defined goal. It's underdeveloped. I don't know how it's going to end. But you could say that there's that future point, right, that is pulling us at the same time. And you see it in embryology. There were these debates between the mechanists and the vitalists in the 19th century regarding the mechanists who were like, oh, it's all about the past pushing the fetus forward moment to moment, causing each cell to differentiate, but it's all about moment to moment. And then the vitalist was all about, no, it's what's shaping the behavior. The Y is the final stage of the baby giraffe or dolphin or whatever that fetus is going to be, even though right now it's maybe just a blastula of 32 cells. You couldn't tell if it's going to be a dolphin, a giraffe, or a human, right? But it's all about the future. So they had these debates that went on for a long time, but I think there was elements of truth in both of them and elements of wrongness in both of them, because it's kind of like, yeah, the point that there was a purpose to why those cells existed and why they were differentiating that had to do with what it would become and the role that that dolphin would play within a broader ecosystem, within a broader continuum of evolutionary so-called, you know, material. But at the same time, it was that blastula existed because there was an egg that was fertilized that happened in the past, right, from 2 other dolphins. So all that to say, you have like a bit of the future and the past both pulling and pushing at the same time, with the whole top-down pulling in or whatever language you want to use. But I like that. It's a fun it's a potent concept. And I'm happy that you just brought up another way that it's manifesting as well in your thinking too. The idea of intuitive reasoning, as you've described it, appears to be, I mean, the way I've used the language, the concept, I never called it intuitive reasoning, but I've always called it naive reasoning. That's sort of what I called it. So any type of use of mind or logic that is derived from assumptions that are sense-based in some way. You know, the sun rises, the sun sets. It doesn't rise, it doesn't set. That's the naive senses are saying that there's this thing called the sun moving around us, because we sense that the world looks very flat. We presume that we're stationary because we're not all flying off the earth moving around the sun.
So you agree that it's in a way a naive form of reasoning?
I think it's naive. Yeah.
Oh, interesting. Okay. That sort of surprised me, because I checked out the book. I checked some of your podcasts and your seminars, and one of them was, I believe, with the Holmes family. And I had a quote somewhere from you where I think you say that getting something out of nothing, it is an intellectual absurdity, something like that. That was your quote. And that to me falls in the category of intuitive reasoning. Because
No, I think that's sort of the ambiguity of language, because it's all about the context of where, like, what was I trying to communicate when I was saying that? Like, that I think that every effect has a cause. I'm not a big fan of the acausality, like things just come into being with nothing causing that. That's where I'm coming from. So, I don't remember the exact context, but no, I think everything has to have a cause. Every effect has to have a cause.
No, that's interesting, because I was expecting a lot of pushback on the very idea that intuitive reasoning is insufficient.
No,
but no, go ahead.
No, like the idea, like all of the examples you gave, that that the whole is cannot be more than the sum of its parts. I agree that that is a very naive sense-based logic. You see a body, you're like, well, the body is obviously the whole of the parts. But it's like, you know, Descartes did that good example. You cut my arms off, you cut my limbs off, I'm still Descartes, you know? And
the featherless chicken.
The fatalist chicken?
The featherless chicken, remember that? That's from some of the, I think Socrates said that the man is a featherless bipedal being, and then whoever it was just plucked the chicken and held it before him. Behold a man, something like that. Okay.
That's pretty funny. Yeah, no, I think that it's scientifically factual that every whole is more than the sum of its parts. And, you know, you could get an example of two people sitting in a lab dissecting a chicken, you know, like one person is looking at a living chicken walking around in their laboratory, and the other person in the next laboratory has the chicken's twin, that it's just, it's trying to figure out what's making it live and cluck. And the first thing they do is kill it to try to, like, you know, get it. Well, what's the living particles that are making the life happen? And there's something very different, though it's the same totality of particles and molecules making up both chickens. One is very much not animated by the thing that is animating the other. I don't know how you feel about that. Well, life is an example of. Do you believe in a principle of life that animates molecules and cells and atoms within living material, or do you think that there's no principle of life, but life is located in the particles making up the thing? Right, I don't know where you stand.
So before I answer that, I just wanted to add to what you said previously. This morning I taught a class where I taught radioactivity. And there too, you know, we have the mass defect, which is that the whole element is lighter than the sum of the nucleons it's made up of. And this mass difference is the binding energy. So here too, we see that the whole is, in this case, it's less than the sum of its parts, but this will be a classic example also from physics where I'm coming from. But now back to your question. So first of all, I've been looking around in, I love science fiction, and I have come to the conclusion that defining life is not as trivial as one might think. You know, NASA is trying to define life, to give it an explicit definition for their extraterrestrial search, you know, SETI, which by now is no longer NASA, but, you know, back in the day. But just putting that semantic point aside, I'm a hardcore materialist. To me, life is just a complex biological, well, for now, at least for now, biological machine interacting. So once you kill something, it's the processes, or one of the necessary processes that is interrupted. And therefore, the whole structure crumbles, like a house of cards, right? Like you have the house of cards that is life, and in the bottom you have a bunch of necessary processes. You know, you have sufficient and necessary processes, and if you remove one of the necessary ones, then it just collapses. And to me, once you kill a chicken, for example, if you electroshock it, you might have stopped its heart. That might be a reversible process, right? You might be able to bring it back up by again restarting the process of the biological machine, right?
Sure.
So to me, we are just biological machines, but that does not mean in any way that it shouldn't take in any way from life's dignity or anything like that. Because if I say machine can be something infinitely complex. And if we just consider our immune systems alone, then those are marvelous nanotechnology machines as we can only dream from science fiction. And then if you combine the immune system, the heart, the liver, which again is a nanotechnological marvel, and then you combine that with the brain and everything, you get an insanely complex machine with all its virtues, emotions, and so on. But nonetheless, purely materialistic.
Okay. Thank you. Do you perceive that the liver, the heart, these things that have evolved in living matter, have purpose, like why they exist, or is it, or do you, because you were saying earlier that you don't think that it's good to assume inherent meanings in things in general. Do they have meanings or purposes or not?
It's fine to assume that. My point is just, when you want to make a theory of the universe, the more ad hoc assumptions you bring in, the less probable that the theory will hold. And that goes back to a sophisticated version of Occam's razor, right? The simplest theory usually is the right one. And I mean that in a Bayesian sense. You know, Bayes in the probability updating as you get new knowledge. From all of our knowledge that we have accumulated, it does seem that the least complex, not the simplest, because the simplest theory to us will be we live because the witch made us, right? That intuitively makes sense because we tend to think in agents and in creators. But the least complex, and I'm talking about this abstract information theoretical concept, I think it's called Kolmogorov complexity. The least complex explanation usually is the right one. And every time you add new ad hoc elements, such as meaning, such as purpose, such as the witch, such as God, such as consciousness, you add on top of that, making the explanation in the end less likely. So that's, I know that it's a bit complex, but
no, that's good. No,
that's the way I see it.
Good.
And so to go back to the, to get back to the question.
I was going to say, just on that quickly, Einstein had a similar thing where he said when trying to communicate a complex idea, you want to try to find the simplest way of communicating it, but never go simpler.
Exactly. That's a Kolmogorov complexity. So I'm not sure if I understand the concept properly because I'm not from information science, but for the sake of the argument, let's interpret the Kolmogorov complexity as the least length message in the optimal most language that can possibly exist, logically speaking, to rebuild this language in a parallel universe, like in a virtual reality that is but not in a computer, but an actual fully, fully detailed virtual reality. For example, to describe this bottle, you'd need, I don't know how many lines of code to do that. Or to describe a theory, you would need this and that many lines. And so anytime you add a new,
that's fine. I can play with that, yeah.
And to get back to the organs, no, I don't think that they have purpose. I think we as conscious beings create purpose and consciousness creates it. But I think as we have matured as a species, we have learned also to ask the right questions. And it turns out, at least from a scientific point of view, and at least until now, that asking why is the wrong question. Asking how is the right question. And I have a little anecdote for that if you yeah.
Okay. Well, just to be clear, just so I can fully wrap my mind around that. So you don't think that the cells that differentiate into the liver or the stomach or the heart or the brain have a purpose?
Maybe we have a different sense of the word purpose, but to me,
yeah, like the liver. Do you believe that the liver? You don't believe the liver has a purpose?
From my definition of purpose, it doesn't. No.
So if somebody said, "Well, why are you getting sick if you're an alcoholic?" And somebody said, "Oh, because his liver is no longer cleansing his body. It's not doing its job. It's not working anymore." That wouldn't make sense to you? Just like.
Well, that's the way we speak. But the way I would interpret it,
doesn't the liver exist to cleanse the body of certain toxins and to, like, doesn't the liver have that role to play within a whole? I mean, you wouldn't.
The way I would rephrase that is the liver is a subpart of a biological machine that happens to have the processes that cleanses our organs. I wouldn't put purpose in there because that would be, in my eyes, an additional assumption, right? An ad hoc assumption. Like, okay, let me just give you a brief example. I have, you don't see the table below me, but let's say this is a table and by accident with my elbow, I bring the glass to its fall, right? That wasn't glass, that was a mic, but let's say I bring this to the fall, right? And it was just an accident. I just wasn't aware it was there and then I just turned around because, I don't know, I got an itch or something. okay, then that action and the subsequent destruction of the bottle on the ground has no purpose. It's a random, accidental event.
Yes, I'm okay with that.
However, when I design and built this bottle, me as a conscious being designing it, it's made with the purpose of holding liquids.
Yes.
So to me, purpose initiates with the consciousness and a goal, right? And so in that sense, I cannot see how a liver, which is an amalgamation of, in my eyes, I don't know if, yeah, it's just an amalgamation of millions of years of random events, such as cosmic particles hitting the DNA of my ancestors, causing the DNA to change and causing a mutation thusly. It's an amalgamation of this happening over millions, if not even billions of years. And then this machine being more and more refined, we also, our DNA is like, what was it, like 80% remnants of viruses, which just happen to become symbiotic with us. And so, yeah, no, to me, it doesn't have a purpose. Just like...
But you believe in purpose that humans cause. So like the cup...
Yes.
The cup...
Consciousness. It doesn't have to
you'll
be...
allow, right? That the effect of conscious decisions and thought and invention can make purpose happen within the human domain. That's okay.
Yes, absolutely.
Okay. But so for things like the chlorophyll molecules' appearance and role within an ecosystem, that you can't allow has a purpose because it's the effect of non-human decisions.
Well, you see, it's a very ideologically laden question, because if you do allow purpose in the way that life has evolved or formed, then you automatically assume a deriving consciousness that made, I guess, the laws of nature such that this happened to evolve like this.
You mentioned earlier the math having usefulness and even predictive attributes, and you gave the example of Dirac's equations using imaginary numbers that were useful to foresee the thing we've called dark matter, or no, sorry, antimatter. Antimatter. Sorry. Do you see number? How do you define number per se? Sort of the substrate of math. Yeah, like number, the sort of substrate of math.
That's a
number.
good one.
Yeah.
I don't know if I can do the question justice. I think my answer would go like, the first thing that pops into my head is, I would say the substrate is, I would call pure logic. And logic is something I have been struggling to define for a very long time, so I cannot get further than that. I think logic is it's a framework of inference, of induction, deduction, modus ponens, and I don't know if I can really define it per se. I think the way I have come to see logic is like a snake biting its own tail. If you want to define logic, you have to use logic, because even language is based on logic, right? So I don't know if I can get any deeper than that, but yeah, I think that's it.
No, that's good. Uraburos. So I just learned that word recently. So
what is it?
What
is the word?
Oh, snake biting its own tail. Uraburos.
Oh, in which language?
Yeah.
Greek.
I think it's Greek originally, but might be Sanskrit as an origin. I'm not too sure.
That's awesome.
Yeah. The idea of number. So you gave an answer I didn't expect, because you're already going into the logic of math, or the logic underpinning math. I was more thinking about just number per se, and because it's something which at some point humans didn't have. We didn't do it, and then we started doing it, and we started communicating it, and it was probably pretty simplistic, but I guess we don't know. We weren't there, but it could have probably arisen out of quantitative, like needing to count things in space or time, right? Like how many coconuts are there over there, or how many suns until I can plant a thing, or something in time, right? In duration, but it was probably like either quantitative or qualitative. Would you agree that that number must have arisen or been invented as a consequence of us trying to look at and explain quantity and or qualities of things?
Physical objects, yeah. Yeah, it's
Yeah.
almost, I would bet good money on that, that numbers were there to count the number of bread loaves or camels or whatever.
Yeah, right, right. And do we see that there is also like we can make certain shapes like a triangle or a square or a hexagon that denotes different quantities, right? In terms of area, space, or in terms of the vectors or the vertices of a
Hmm.
triangle or a square or a pentagon or a hexagon.
Yeah, like, yeah.
Yeah, yeah. Like so, one would be 3, 4, 5, or 6. In terms of the vertices of either one.
This is, you're
Uh,
probably familiar with this, but this is also how the Arabic numbers came to be, right? Like the 9 or the 4 has 4 corners or
yeah.
4 bars, or don't
Well, it's
remember.
like 4 angles are located in that
Yeah, 4
symbol.
angles. Yeah.
Right? Or the other 3 is like 3 angles in the 3.
Yeah,
Yeah,
exactly.
yeah, it's fun. Um, the would we see, even though that could be considered to be like squares, pentagons, hexagons are attributes of math, one could say. Um, we also find them in nature, right? Like Saturn, the top of Saturn is a hexagon, right?
Oh yeah,
We don't
that
know
is that
why.
is a mystery. That is
That's cool, eh?
fascinating.
Yeah, but it's there. It's like, or so that's fun. Or like snowflakes, will tend to what H2O will tend to organize itself and bind with other H2O molecules and form what we recognize as not a pentagon or an octagon, but hexagons, right? Like that happens.
Yes, and I even
Carbon.
have a no, I'll let you finish the thought, but I do have a continuation of that. It goes even way deeper into quantum mechanics and goes further than visible, tangible geometry. Unless you want me to say it now, if you want to.
I'm open to that. I like,
All
yeah,
right,
sure. I'm
so
curious.
so first of all, just a little aparté, because it's a nice conversation. I only recently stumbled upon that thing with the Saturn. I think it's less than 2 years ago that I saw a pic and I was like, this is shocked. Saturn does not have a hexagon on its pole. And then I was like, oh yeah, it actually does. And I looked it up
Yeah.
and it's yeah, fun fact. So I think I also heard you speak, or maybe read you somewhere that you put a great value on these elemental shapes, and you somehow draw them back to our ways of perceiving and thinking things. And I wanna do another part where I reconcile, where I don't necessarily see the part where it goes back to our psyche and how these things are elementary, but there is something very similar to that, which is in physics, symmetries are very fundamental. And there is a great theorem from a lady called Noether, which is that with every symmetry comes a conservation current. And here's another fun fact that is a consequence from that. And symmetries, in a way, are these geometrical objects, right? Because they have a lot of, I guess the symmetry is the generalization, the abstraction of these geometrical options into infinite or as many dimensional space as you like. And it doesn't need to be geometrical symmetries. There's also other symmetries. But here's one. We assume that the laws of nature are constant in time, right? This is by definition. That means that the laws of nature are symmetrical through this transformation that is a time transformation. Here you see that symmetry is more general than geometric symmetries, right? Okay? And Noether, well, if you apply this Noether theorem on that symmetry that is time for the laws of nature, you see something that is conserved. And that thing that is conserved is time. So time is nothing but the conservation current of the fact that laws of nature are presumed to be symmetric with respect to time. And so here you can see one example. There's plenty of other examples, like the conservation of charge, conservation of momentum are all consequences of the symmetry of time and space. Like you assume that the laws of nature hold towards X as they hold towards Y, as they hold towards Z, right? And the conservation part of that will be the conservation of momentum. And I think this might go to what you're saying, because to me, symmetries are as I said, the generalization of geometrical shapes into any crazy vector space or other space you want to have. And in physics, symmetries come with conservation quantities. And this is something that is also very nice to say to high school students. Like, as I said, I've been teaching. Energy is nothing other but that quantity that pushes us towards time. This is a very simple way of defining energy. Energy and time are just like cousins. Just like matter and mass, energy and mass, according to Einstein, are the same, right?
And I guess I like that. Yeah, it's some fun concepts there. I guess if someone were to ask you as a follow-up, why would it be wired to do that instead of something else? You would have to say, I'm assuming that's an absurd question that denotes purposefulness, and so I shouldn't go there, or would you have an answer that's different?
Well, no, not at first. I don't think I would. Perhaps I would after a while of thinking, but generally speaking, when you come with the why question, usually what is meant is how come that, right? But if you ask for the purpose, then I would have to inquire into the purpose of why the math turns out to spit out Noether's theorem, right? I would have to inquire into why the universe is that, and it's just that whenever you ask the question why into the void of the universe, there's usually nothing that comes back. However, whenever you ask how come or how does this work, usually something comes back. And so that, I guess, to me is in a way that the only way of answering how is by putting in a bunch of assumptions, such as, I don't know, math was created in such a way such as to give us this current, but I have no basis to draw that conclusion from, right? I don't know if it's a satisfactory. I guess, long story short, no, I don't think why is the right answer. The right question.
I think that's what I figured as much. Okay, I just had to be clear on that. If back to the question of you're correct that I place a high value on things like the Platonic solids and these elementary shapes. I do so. It's true. I do. But I do it also because I think that it does create a foundation around which I think about how I relate to understanding things that are beyond space and time.
Okay, could you elaborate on that? How do Platonic solids, which it's triangle, it's the not the cube. What's the two-dimensional cube? The square, the pentagon, the hexagon, and these shapes, right? Or am I missing? Does he also have three-dimensional?
No, it's just the you're right. It's the if you take the most elementary sort of prime numbers that are expressed in the form of symmetrical geometries in two-dimensional space or areas, then yeah, you'd have the triangle. Well, the square is a bit of a cheat, right? Because it's not a prime number, but you got the square, the pentagon, and the hexagon. But the hexagon is actually not in there, so it's just the triangle, the square, and the pentagon, which will be able to fold into each other, getting out of two-dimensional space in order to create closed structures that have certain attributes, like that their vertices are equidistant from a center point, that they could all be nested within a sphere and have a sphere nested within that touches each of their 5 central faces. And there's only 5 of those types of three-dimensional shapes constructible that are possible. You could try to have more, but it wouldn't qualify as one of those 5 Platonic solids. it would have either, you know, like a third sphere or non regular surface areas. You have the Archimedeans that are a bit of a mixture of the 2 or 3 different shapes. But yeah, these polyhedra have certain attributes that I find very valuable that are rooted in these 3 basic shapes.
Okay, I think I'll.
Oh, you're on mute.
Yeah, I just muted myself. I
Okay.
think I'll look it up and blend for our viewers a picture of the.
Oh, that would be
Platonic
nice. Yeah, a little image so people don't have to just imagine what we're talking about.
But then how do you make the bridge? How do you build the bridge between the Platonic basic solids and then subsequently the way of thinking and viewing, what did you say, beyond time and space? Or larger?
Yeah, because I could when I make the solids, because it's good to construct the square, the triangle, the pentagon, and to figure out how do you construct them yourself instead of just, because a lot of people were kind of mistrained, I think, in school to just get the right answers, and you know, it's like, yeah, you just cut it out, make a shape with 4, you know, four sides to it, and you've got a square. And it's like, yeah, but how do you know that that's a square and not something that looks like a square? So that requires, you know, a bit of actual experimentation with a compass to see if I can actually get through. You probably have your students do that if you're a teacher. I'm guessing this is probably something that you know.
I must disappoint. I might have been one of the last generation actually doing that. You know, using the compass to draw the equal distances, because nowadays they all have computers. In class, there's not a single person with a piece of paper.
Fuck. Okay, well that's sad. Well, but there's a joy, right? Like when a kid actually takes a compass and they're like, okay, I'm gonna have a circle, and then they're trying to figure out, well, how do I carve divide the circle into 3 equal segments, which will give you a triangle, or 4 or 5 equal segments, or 6 equal segments.
I know exactly what you mean. Like drawing the arcs to and then they cross, and then you have the right distances, and you can.
Yeah, and then you're like, I know why that distance now on the side of the triangle has a relationship to the radius. That I now know where it comes from. What was my reason for dividing it where I divided it instead of some other infinite possible place I could have selected arbitrarily, you know?
There is something to that, yeah.
Yeah. So that very process, and then it gives a kid a very living idea of what their mind does when it is animated by a purposeful motion. Because I'm like, I want to figure out a solution to something I am ignorant of, and so there's like that future governing the testing, the hypothesizing as the kid is trying things out, they're not working, and then that eureka moment is very satisfying when the kid's like, aha, that I get it. It's that. This is the reason. I know it. And then you could play with that triangle that you've built and then see how many you could add together to fill space, right? And you're like, oh, there's 6 of them that fill out nicely around each other, and they leave nothing in between. And then you could start like playing with them, and then you could do the same thing with a square and see how many fit together nicely.
I imagine your desk with a bunch of cut out little triangles, and you're playing around to build those thoughts.
No, I did a lot. Yeah, that's exactly what you would have seen. and then the pentagon's the hardest one and it's the most satisfying. That one took me like months to figure out. Like to construct the pentagon is so hard, because it's like if you don't already have the right answer, that you're like just following somebody who told you what to do, but you're trying to figure out yourself. It involves getting into you got to figure out the Pythagorean theorem first to figure out why is that true, because it has to do with the diameter of the circle and the radius squared. So you have to take both the diameter squared and the radius squared, and then you have to get like the hypotenuse of that to get an answer. And then you got to play with that. That doesn't give you the full answer. That only gives you a partway answer. But then you could play with that and start figuring out how that relates to the wrapping around of the this new distance will then allow you to wrap around the circumference of the circle if you do something else first to it. And so these are really fun things. And then when you get it, you're like, oh, now I know why there's the golden section, this inexpressible mathematical number of 1.61 blah blah blah. I forget. It's a non-expressible number. If you try to just express it as a number,
numbers, yeah,
you'll spend it's purgatory. You know, like the best calculating machines we have only been able to add a few trillion points to it, but it doesn't look like there's ever going to be a closing off
Yeah, these are
of some of these.
the irrational numbers, like pi. They're infinite number. That in terms of numbers, they're infinite.
Yeah, because they're not but they're knowable if you don't think in terms of simply one-dimensional space, right? So
Yep.
if the mind allows itself to go into that higher two-dimensional space, then they're knowable, but as a number from a one-dimensional descriptive point, no, you can't wrap your mind around it. But you can know it from the standpoint of a pentagon, right?
Or from an
Which
equation.
requires, huh?
Or from an equation. I think it was
Or you could put a
7/5
symbol of
something.
square root.
Yeah, I forgot what it was. I forgot what the definition was, but yeah, you can define the golden section by terms of numbers.
Yeah, like square root of 5 minus 1 over 2, or square root of 5
Oh, you know
minus
it, you
1
know
over
it by
3.
heart. Yeah.
Yeah. But it means something, because you could memorize the symbol of square root of 5 minus 1 over 2. You could take that as a symbolic thing that we've created, that like, so like we've made that symbol, that's backwards for the camera, but anyway, we've made that symbol. It's, we've made the symbol of 5, as we pointed out, for the Arabs. The Arabs had their 5,
Yeah.
which again looks like a 2 probably for you, but there's 5.
No, it looks all right. It's fine.
It looks okay. It's for me, then
Yeah.
it looks backwards. But there's like 5 different 1, 2, 3, 4, 5
Corners.
corners that have little. So all of these things are created, and so if you haven't done the work of constructively proving where and why the golden section originates as part of a construction that would be necessary if you want to understand a dodecahedron, which is like 12 pentagons wrapped around each other.
Is
right?
that the dodeca? Yeah, that's the Dungeons and Dragons die.
That's the Dungeons and Dragons dice, exactly. Yeah. Yeah, that's where most people know it. Or the icosahedron. It's also in there, but it's not as obvious because the icosahedron just has triangles. But if you haven't done that, then simply memorizing the symbol won't have the value or the power of playfulness. You wouldn't be able to play with it as much as you could if you did the work to know what it is that's being represented by the symbol. So this deductive, inductive, or logical, let's say deductive, inductive reasoning associated with math at any given moment. Math does do what you described it does. It helps us express deductive and inductive logic, but it doesn't account for how the math can qualitatively transform and improve either. It only allows for, like, at any given moment, what math is in the 12th century is different from what math is in the 16th century or the 19th century or today or ancient times, right? At any given moment, there's a snapshot of what is the language of math at that moment. And in that moment, it describes everything that has been discovered deductively and inductively using certain assumptions and certain, but it doesn't explain how these discontinuous breaks happen, because if you compare it to the snapshot of post-Keplerian math or Leibniz's infinitesimal calculus math, which was, people were ignorant of the infinitesimal calculus before Leibniz made the breakthroughs.
People were ignorant of the concept of zero until like a few hundred years ago, right?
Exactly. So there's something more than the simple computer logic of deduction and induction that is associated with the math's improvement in terms of its ability to better express or reality. Would you agree or disagree with that?
I have two things on that. The first is just to try to reinterpret your question in my own words. So in essence, if I understand it correctly, those basic forms, not the forms perhaps themselves, but tinkering with them, is to you very much connected with the process of discovery in general realms. So this process of discovery from this very elementary geometry translates to the very same process of discovery in other domains that are not just geometric. Is that about it?
That's correct enough.
Okay. Yeah. Now to the other part, which you just mentioned. Are you familiar with something called Gödel's theorem?
Yes. The incompleteness theorem?
The incompleteness theorem, the very same.
Yes.
And it's been a while that I looked it up, and I keep looking it up, and I keep forgetting it. And there's a bunch of interpretations, some of which are more or less true than others. But I don't know if I can do it justice from memory, but I think from memory it's something along the lines of well, he sets up the premise by saying, okay, first of all, we got to notice that most of all functions, let's say simple mathematical functions, are infinite, and therefore they're outside of our, so in the space of all possible functions, you can do the function that is x plus 1/2 x plus 2x plus, I don't know, the exponential plus, and it will be an infinite series. So in the space of all functions, the ones that are not infinite is an infinitely small portion, right? If you do a Venn diagram and you have a break circle for all possible functions, the ones that we can possibly ever know because we are finite beings will be an infinitely tiny dot on that Venn diagram. So first of all, most of math is out of reach for us, right? I think he set up the premise like this, and then he showed that by using mathematical proof, there are certain things that math cannot prove in and of itself. So math cannot prove its own consistency with its own structure of proof, something like that. And one possible interpretation of that, which I believe was a correct interpretation, is that there is something about understanding that falls outside of the of the system of proofs that math employs. I think that was one of the interpretations. So in a way, understanding is something that is outside of just mathematical proofs. Now, people will say, you see, this means this is esoteric and this is that there is some sort of soul and everything. That will be a far-fetched jumping to conclusions. The only thing we can say from that theorem is that, at least in the context, in the way Gödel set up what a mathematical proof is, which is a fairly airtight definition, I don't remember it exactly, there is something that falls outside of it, which is understanding, which overarches the process of discovery in mathematics. Something like that. So yes, definitely there is, I forgot what the original question was, but yeah, definitely there is something we can that it's mathematically proven that there is something that goes beyond just mathematical proofs.
Cool, yeah, and that was the idea of like how the math is able to become perfected in time. So the language that maybe started very primitively to count camels or rocks or days or like, you know, cycles of the sun or something that was very primitive and probably more quantitative at some very early primitive stage of math has moved through discoveries that have been made to become more enriched as a language, a symbolic language that is deductive and inductive, but that the process of the discontinuous leaps that happen from like new discoveries being introduced, right, that allow for the entire language, the theorem lattice that makes up the whole language to improve and better reflect reality, that can't be explained by the simple acts of deduction and induction that are located within any given snapshot moment. So there's that something more, which I'm saying has a lot to do with the freedom of playfulness and that higher intuition that is reasonable, that is gained when you discover things like the construction of the triangle or the construction of the golden section, and you can play with that when you've discovered it, and all of a sudden you have a power to do things mentally and creatively that you wouldn't if you had simply memorized the right answer to get the same effects as the student next to you who didn't discover it but simply copied something and might get correct answers. They will have a reduced power. I'll call it power for the lack of a better word that I can find right now, but they will have a lack of potential that could actualize new discoveries that would be better, or to understand things that the other student who did the work has access to. So there's that, but it's not material in that sense. This is my immaterialism.
I have a question for you here at this point then.
Yeah.
So you've probably tinkered more or less with ChatGPT, right? You've probably played even with the new one, ChatGPT 4, and it seems, no, you haven't? You must
I haven't played with it, but I have fun. I enjoy the AI.
There you go. So it seems like the AI understands you when you ask it a question, right? It definitely feels like it, and I believe for most people that would actually pass the Turing test talking to ChatGPT. Yeah, I think you might with the new one. And so Here's my question to you. Since you just said that there's something that goes beyond just well, it's mathematical proof. It doesn't necessarily go beyond deductive and inductive reasoning, because to me, deductive and inductive reasoning are in the category of understanding, not necessarily mathematical proof, because the Gödel theorem only talks about mathematical proofs. There's no deductive, inductive reasoning there. So it's just the structure, the way a proof goes, right? Yeah, that's a side note. But so, yeah, the question to you, do you think AI can soon take over this precise process of discovery, this creative process of deduction, induction, perhaps hypothesizing new things and then using proofs to maybe test them?
I think that it will be limited to some combination of deductive and inductive reasoning, and that might be able to derive from a descriptive type of, because it has access to all people's descriptions of the creative process that are available in the digital world, that it can derive and create some relative approximation to if asked to do something similar into the unknown. But I don't think that it could actually do what humans can do if we're being healthy-minded, creative people.
Yeah, that's, you just mentioned something that I keep not seeing in the description of science. Science is an inordinately creative process, in fact, because
Yeah.
I mean, you gotta be crazy creative enough to come up with the idea that space-time is a at least four-dimensional manifold, right? Because Euclidean space is not good enough. You need a more abstract notion of space, which is a manifold that warps as energy is put in there. It's just, it's creative. There's no other word for it. But since we're approaching the 1.5 hour mark, and
I just canceled my my other my 3:30, so we can go on for another half hour if you want.
Okay, I hope it wasn't anything important. Or,
it was a small conference call. I just pushed it down towards tonight, so it's fine.
Okay, that's cool. All right. So do you have anything else? Well, let me ask you another thing, because it's been a while that we talked about this, but it goes back to that. So one little pushback from my side. When you talked about the math throughout the centuries, to me, the way I see it, math has only existed for at most 400 years. It's only after we started having the Arabic numbers and having some actual operations that are more or less formalized that we can really talk about math. Because everything, see, the thing is, and this is a famous quote from Einstein, he says, I don't know what the quote was, but something on the lines of, as a person, I'm okay, but armed with a pen, I become smart, right? Because this is the thing. Math is not just a language of nature, it's also an inordinately useful, powerful tool, because just by dealing with the little symbols on the paper, you can actually do crazy creative things and inferences about nature, right? You just take Einstein's equation, you tinker a little bit with his equations, and lo and behold, you have, oh, Einstein, dude, this thing says that there should be something like gravity waves from your theory. And lo and behold, decades later, we actually measure them. So just to say that. And then the question to you, are you familiar with Julian Jaynes and his book on the origins of consciousness in the bicameral mind?
No, I'm not.
Oh, I think you would actually like that. It's a controversial thesis, but it's very well argued in his book. It's Julian Jaynes, like Jaynes. And well, I can put it in the description if anyone cares for it. It's a very interesting book which basically stipulates that until only about maybe 2 to 4 millennia ago, people did not really have consciousness the way we have it now. They seem to have a bicameral mind, right? With
how does he define bicameral? Like, how does he think about that?
I don't remember exactly, but it's something along the lines of people did not have a full consciousness back then. And that brought me back to that thing which you said about the maths and the discoveries. And it's just, it will fit right in here if I remembered more of it. Are you looking for it?
No, I've got all my Greek books on Apollonian Cohn's and Archytas's works on the doubling of the cube. I mean, when somebody would say that there wasn't math before 400 years ago, what about all of the works?
That's geometry. I mean, yeah, they are very close cousins, but to me, math is the manipulation of symbols on a piece of paper, which then leads to much greater discoveries than.
You
So,
had things like the Pythagorean theorem, which derives
okay,
from
okay, there is
intersections on a
math.
circle that shape what became trigonometry later on, as far as
Yeah, yeah,
the
yeah. No, you're right.
right
You're right.
angle
I take it back.
triangles.
I take it
Yeah.
back. There was math before. It just feels like math only started about 400 years ago. But then again, we
Oh,
must
well,
also.
it definitely. I'll agree with you that it took an upshift. Like it shifted gears into a new domain of capabilities, for sure. I'll go with you on that one. Yeah. Well,
So
yeah. Sorry, finish your thought. Yeah.
yeah, so Julian Jaynes in his book, I think you would love it. I think you would find it fascinating. And he also talks about, what was the word? There is this initiation ritual somewhere in Greece, and there's an adjective that derives from it because it was so shrouded in mystery. And the adjectives is a synonym to mysterious. You know what I mean? You're an expert on these Greek matters.
Sacrament.
Let me look. Synonyms, mysterious. It's a town somewhere in Greece. It's like the initiation rituals of. It's not mystical, uncanny. It's not in the list here.
It's okay. All right. Well, you can describe it instead of saying its name nominally. It's fine.
So there used to be this big fancy rituals in some town in Greece, and the adjective derives from that town. It's the mysterious.
Not elusive.
Maybe it's Eleusis.
Oh, like
Maybe,
elusive. I guess. Yeah. Okay. Yeah.
yes,
Elusive.
yes, yes. I
Mystery.
think that might
Okay.
have
Sure.
been it.
Sure. Okay.
Yeah,
Yeah.
I
Yeah.
think that rings a bell. And so he goes into he deals with those mysteries, and he talks about how anthropologists were there and they found psilocybin and other psychoactive substances in the dishes. And so the
Sure.
assumption is that they took these drugs, that was the initiation to go through these altered states of mind, and then they became members of Eleusis, I guess. And there was like
Well, there was
priests
a
and
lot
all
to
sorts
it.
of.
Yeah.
But yeah,
Yeah.
anyway, and I think he links those rituals with the first beginnings of the actual conscious state of. But this is another topic. It's just
Well, that's interesting.
mention
He's actually talking about that, eh? Well, I'm going to read him for not to sort of see why he's wise, but I do think that he's probably highly vetted to put out something that is touching on something. I've been spending the last several months looking quite deeply at these mystery cults and their continuation through the Middle Ages, through the Renaissance into the present age. So this guy actually looks like he might have some useful material in there.
I am sure he
What's
does.
it
Yeah,
again?
I'm sure. Julian Jaynes.
Julian Jaynes. Okay. Hey, did I ever tell you something about Kurt Gödel and how he died?
Oh no, tell me.
He starved to death. No shit. Yeah, he starved to death, and it was really bad because for 15 years he was he became quite convinced that Bertrand Russell was part of a broader conspiracy to destroy and obscure real scientific discoveries, and especially Gottfried Leibniz, and wanted to destroy him because he didn't just make an enemy out of Russell through his 1933 opus there, but and Whitehead was more classy. Whitehead was like, "Hats off to you, good sir. We overlooked this one," and he put his Principia into the back burner and said, "Okay, we screwed up." Whereas Bertrand Russell never apologized, never acknowledged Gödel's proof, and how it dismantled the underpinning axioms of the Principia Mathematica series. But Gödel spent the last decades of his life working to try to complete Leibniz's work on a universal language, which I don't fully understand, but Leibniz had put a lot that was unpublished. Like 90% of Leibniz's work was unpublished. Crazy amounts. A lot of it not even translated. But Gödel had translated a lot of it and had noted that that there was a conspiracy to eliminate the memory and knowledge of what Leibniz's method was. And so he would only allow his wife to cook for him. He wouldn't trust anybody's food. And when she got sick and went to the hospital for a week, he had no one to cook for him, and he got too sick.
No
at that same
way.
time to make his own food, and he ended up starving to death. And it's really sad. But um, it does get at something I've been trying to bridge, which is this history of politics and the battle over ideas that around what policies and what political structures will organize us or have us self-organized, and the battles in science that underpin also these things. I find it very I haven't found anyone who's done the work on this yet, but I know that the highest levels of the British imperial like command structure of the 18th century, for example, which were behind also the growth of John Dee, Francis Bacon, the Rosicrucians that created the Royal Society. To begin with, it was all a Rosicrucian thing, right? Where these figures were operating in intelligence networks, they were operating with political objectives and goals in the real world, while at the same time they were creating things like the Hellfire Club. So the entire British High Command, the Chancellor for the Exchequer, all of the leaders of the British East India Company that were trying to enforce a global system of feudalism, of population control, a new Roman Empire, were all members of the Hellfire Club, all of them, and they were doing Eleusinian mysteries. As one of the members even testified and wrote a book about this, the guy whose grandson ended up killing Lincoln, John Wilkes, who was a very leading figure, a Kabbalist. He was a member of the Dashwood Hellfire Club, and a member of the British Royal Society at the same time, which is not a coincidence. And yeah, he talked about how they were doing Eleusinian mysteries that involved sacred sacraments that had been maintained since ancient times as
Yeah.
part of the initiation process of the elites.
Oh,
So I
this
think
is
all of this is
Julian
very
Jaynes,
interesting.
Julian
Yeah,
Jaynes material right there.
that's his material, eh? Oh, I really need to look at this. That's good. Okay.
That's a good one. Do you have anything more about what I said on the argument, or maybe I can
Yeah,
mean,
I mean, sure.
either you have one more note, or I would just ask the question to you: where and why and how come do you see purpose in the universe, in nature?
Oh, okay. Well, instead of see I the way you mentioned in your introductory remarks about the danger of transposing our internal subjectivity and
Yes.
desires onto the universe, I agree with you that that's a huge danger, and Plato dealt with that in the Protagoras dialogue, with the thesis that man is made in the image, man is the measure of all things, and Protagoras is a leading sophist who's in the midst of corrupting the people of Athens as Athens is becoming dominated by the cults
Interesting
of
that you would
Eleusis.
call him a sophist.
Protagoras?
Yeah. Oh, Protagoras. I thought Plato. Sorry, my bad.
No. Plato was exposing Protagoras in
Okay,
this
okay.
because Protagoras is saying man is the measure of all things. That's the core of his philosophy. But Protagoras is also a real person and a real sophist in ancient Athens that Plato is talking and he's interfacing with the mystery cults as well as part of the takeover and corruption of Athens as Athens is turned into a backstabbing empire, kind of like what happened to the United States after the murder of JFK. It basically started going crazy and became dominated by its own worst attributes, or its own, the thing that it broke away from is what ended up dominating it more and more after World War II even.
This is
So
interesting.
something similar happened to Athens. Huh?
So sorry, just little interlude. This is interesting that you mentioned the JFK thing, because when I wrote my article on neocons, I don't know, maybe if you're interested at some point you can check it out. It's on Substack, and the guys from the Duran were kind enough to put it up, by the way. So I got a bump there. But when I wrote my article on neocons, where I say basically that the U.S. foreign policy establishment is captured and dominated by this psychological type, which I call the neocon, which is also an ideology, by the way, and I just define it, and I go over psychology, I go over anthropology to define it properly and to give it a concise definition. I didn't look it up, but I also said roughly since the 1960s.
Yeah.
Right?
No, that's a good intuition you have there. That's correct. It's a good informed insight.
Yeah,
That's
go
when
on. Sorry, I just wanted
it was
to.
already going on before that, but no, but that's good because a lot of people miss that. They think of it as a more newer phenomenon, and it's important to go really to that moment at least. Now the reason why I'm just bringing this up is that I see that there's an element of truth, but also a big lie and a fallacy in Protagoras' thesis, which has been replicated in all of those who anthropomorphize the universe, which is that I start from the opposite end because I follow Plato's method. So I look at Plato, who agreed to a limited extent that there is something that we can measure by looking inside of ourselves that allows us to measure both qualities and quantities outside of us in the mind. But it's not through our feelings or our desires of how we want things to be that we can just impose that onto things outside of us, but that it's in the power of reasoning and discovery that as a process we find it's displayed outside of us. And I was giving an example of Saturn, the hexagonal configuration on Saturn, the hexagonal configuration in snowflakes, or for example, even the golden section that manifests disproportionately in living material that doesn't manifest itself in non-living material, non-living matter. So the golden section, which, you know, ancient Greeks or even in the Renaissance were animating the thinking behind the architecture of the Parthenon or many of the cathedrals. Even there was like a sense that there was a sort of beauty in this specific proportion that could be found directly as part of the construction of the dodecahedron, which itself has demonstrated a value because there's proportions that occur when you take the 5 Platonic solids that are derived from the dodecahedron and the golden section and look at the nestings of the solids in lawful manners, not arbitrary, that provide proportions which were very useful in the pursuit of discoveries like what Kepler did in his Mysterium Cosmographicum in 1594. That served as the basis for his later discoveries of the new astronomy and the harmonies of the worlds in 1609 or 1619, that produced very, very useful, powerful planetary laws of motion, which also have usefulness in the quantum domain still to this day. They're among some of the few elements of classical physics that are still very useful in quantum mechanics, are the Keplerian, especially Kepler's third law.
Wait, was the third law the one where equal times equal surfaces, or was that? So wait, the first one was the ellipsis. The second one was equal times equal. So basically, you know, faster. You're faster when you're closer to the sun, and then you orbit slower, and then you get faster again. And then the third one, wait, don't say it. Oh, the third one was the cubes of the radii correspond to the squares of the radii, the semi-axis of the ellipsis correspond to the cubes of the orbit times, right?
Close. It's the cube of the semi-axis of each of the planets have a relationship to the square of the periods of each of the planets, and that square cube relationship has an invariation within all of the planets until we got to Mercury and discovered that
we need general relativity. Yeah, exactly.
Yeah. But that harmonic law is which was directly taken up by Kepler in his Harmonies of the World. He's directly citing Plato's Timaeus, and he's making a point that all of the work he's doing is directly coming out of the hypotheses and the work that Plato had developed within the Timaeus dialogue of the nested solids and the cube square relationship, specifically, and also the idea of harmonics of beauty.
You do something we scientists never do, which is go to the original source.
Oh, it's so good, dude. No, I mean, like even like reading Kepler's Optics, you start seeing like where the roots of a lot of the things that we were told were all created by Newton, who doesn't make very transparent his method of discovering things.
He was a bit of an artist, to be fair.
Very, yeah, and alchemist as well. But but Kepler's super transparent, and he's giving you really full access to all of his powers, of all of his hypotheses, his mistakes. He wants to take you for the journey, and so does Leibniz too. When you read like Leibniz's, he had a science journal, the Acta Eruditorum, with the Brunelleschi brothers, especially Jean Bernoulli, who co-discovered the work on the brachistochrome, the infinitesimal calculus with him, years before Newton ever made any notice that he had discovered it outside of Leibniz. But the difference is when you read the Acta Eruditorum of Leibniz, he's a Keplerian. He's following Kepler. He's taking Kepler's challenge in the New Astronomy, Kepler's 1609 New Astronomy, to future mathematicians to come up with a language that would explain the types of nonlinear changes that are happening on an elliptical orbit, where every single moment is a different, speed and distance. So Kepler didn't have that language, and that's what Leibniz read and chose to take up as his method, as his challenge. So I'm just saying all of this as a way to sort of spin my point, which is that I see that the power of I think of human as natural. I see that humans and the mind are not outside of nature. And because we're a part of nature, created by nature, that the laws that animated the creation of nature is also expressed in some way within the human experience, but not in the way that Protagoras is saying, or the naive logicians are saying, but rather in the process of potent creative action, mentation.
So
and
would
yeah.
So, would you?
I see that we are the reflection of the universe. We're a part of the universe, and to understand the universe would not, and that the universe, the causal principles of the universe, in my view, are embedded in all parts of it. As you pointed out, the holographic concepts are useful in that.
Yeah.
And such that if that were true, then looking at those creative, potent, reasonable, creative processes, which are best expressed within human mind, would also give us an insight into the attributes of that whole universe of which we are a part. So that's where I would just.
So I'm absolutely on board with that one. I'm totally on board with you. That's basically my thesis. It's we're the custodians. Well, first of all, we are the custodians of this generation, this planet, right? We're not the most important people in place. It's like on a social level, and on a nature level, we are just little results of the big laws of nature. And therefore, here my question to you: would you sign the document if I gave you something which stated, since we are part of nature, we have, well, at least no a priori, unless we prove it otherwise, no right to impose our values, ethics, morals, and something on the universe and then pretend that those are the basic laws of nature?
I like context, so I would have to. I'm all about context, so I would say
right. So this is
not right if it, but I would definitely read it and think about it and see what else is said,
Okay, fair enough. But then this brings me to another thing, because you mentioned that whole way of thinking, which again I call epistemology. We can call it school of thought. And then just a question to you: you said that you were not too impressed with David Deutsch, but to me, at least in his book The Beginning of Infinity, David Deutsch lays out an excellent epistemology. It's like the best formulation of Popperian, I guess, scientific method that I've seen. And just as a side note, well, no, there's no need for a side note. But what would you have to say against David Deutsch's Beginning of Infinity and his way of reasoning?
Since I would say that for the context of a discussion that's going to be on record, I would say let's reserve that as I get a chance to properly read through more of his material, because I don't want to just criticize somebody that I haven't really dove deeply into. So it wouldn't mean very much if I were to give my opinion, having not done an extensive amount of work, or at least a respectful amount of work that would be sufficient to then generate a qualitative response. I wouldn't feel right about putting that out there. So let's put that on pause. Let me incorporate a bit of reading of Deutsch and then get back to you.
If I can recommend anything, The Beginning of Infinity is, I'm not sure about his other works. I think I read one of his other works, but The Beginning of Infinity is, to me, I have yet to find a better encapsulation of what I call with epistemology, of what I call the scientific epistemology.
Okay, well, let me order it. I'm gonna start with Julian Jaynes's Evolution of the Bicameralist Mind for my own. That falls directly into what I'm working on right now, so I'm gonna make that one a higher priority. But I'm gonna include the Deutsch one into my. It'll be up in my library in the coming weeks behind me. I promise.
All right, I think. Do you have anything more? Any pushback to what I said, or any other remarks?
Well, I mean, I think we've been pretty transparent with ourselves and with the audience over our general philosophy or
Mm.
epistemology and approach to life. I think people have a sense probably better now than they did at the beginning of where we are you what we have in common and where we differ so far. So I think we set out what we set out to do, we generally did. It wasn't, I mean, it wasn't the type of debate I was expecting more of a, but to
Yeah,
do like
same. I was
the
expecting a
conventional
fight.
debates. Yeah, I know. But I guess it requires more of like a moderator and then like throwing things back and
Mm.
forth. But this is just an enjoyable chat, you know, that I felt like we just had.
I was
Um,
actually thinking of incorporating a moderator,
yeah.
but I just it didn't it seemed too formal, you know. And I think if I had known that this might go on for 2 hours, I might have added more structure and perhaps a moderator bit. But I was thinking just in an hour, maybe we can just do it the two of us, you know, because
No, I like this.
a moderator also kind of does creates a gap between us, right? Like
Mm.
a canyon between us, like a distance. And so I
Yeah,
think
yeah, yeah.
this. But yeah, as I said, I was expecting much more of a fight. I was expecting you would like contradict me on the idea of intuitive reasoning. You would say, no, these things are actually absurd, and here's why. I was
Oh, right.
expecting.
So no, I would actually say that, and then, yeah, it's not to push back on anything actually, but yeah, on another point on intuitive reasoning, that something is either you know, either A or B, but something can't be both
Mhm.
A or and not A. I disagree. I think that something can be both A and not A at the same time because I think that I'm both infinitely divisible, but I'm also a one. You know, like but am I one and I'm not infinitely divisible? No, I think I'm both of those things. So is that you know there even the idea of the wave particle thing, like the idea that there's a naivete regarding like what is this thing called light. We use the term light. We honestly don't know very much about it. And the very fact that it does seem that future states of the light are interfering in the so-called present. I don't know. Actually, one thing I'll ask you, how do they isolate an individual photon? I never quite figured out what do they do because I've seen the experiment as far as
Mhm.
like you know quick sped up shots of like individual photons
Mhm.
falling on a backdrop of a photoelectric of a plate that showcases
Mhm.
the um, the wave particle dualism. But how do they isolate a photon such that they make that work? Because I can't figure that one out.
I must profess my ignorance on that one. I can imagine that you have a greater particle that you can control, like a massive particle, ionized, because once it's ionized, you can control it in a magnetic field, right? Which is
One
an easy way.
particle,
A single
I mean
particle.
a particle or a photon?
Yes, one high energy particle,
Yeah.
which you capture and isolate by means of electromagnetism, which is the force which we interact with best because we have very precise measurements and tools for that, right? But this particle is excited such that at an unknown time, it will de-excite by emitting a single photon of a desired energy. So I can imagine that you can isolate an excited particle, put it in a chamber, and then have it such that once it emits the photon, you capture a single photon. It's a thesis, but I must profess my ignorance on this one. It's just, I think,
If anybody's watching, that's an interesting theory. It sounds very elaborate, and they were doing this back in the 30s. So I'm wondering
oh, back in
maybe,
the 30s already.
well, isn't that when the double slit experiment was first set up, or maybe it
Oh
was the
no,
40s?
those electrons. Those were electrons with a
Those were
sufficiently
electrons
rare event that
that would
you would
then
have a
behave like
high.
a wave in time.
Yeah,
Okay.
exactly. Yeah. I mean,
Okay,
the
and that you
wave.
could create by I guess an X-ray that would hit an electric plate that would then result in a single electron being hit off the plate and like
Yeah, genau.
yeah, okay. All right, interesting. Well, that being said, all that to say, yeah, the idea of us being animated by both, in my view, um, where we're being shaped by the past, but also the future at the same
Mhm.
time, not either or. We are both parts and a whole, not either or. I'm okay with all of these ambiguities. That's perfectly okay in my epistemology.
Okay. I also had an elaboration of how you can actually get something from nothing, how quantum field theory effectively predicts that, and you can find it in the Hawking radiation from black holes where particles are created out of nothing, and then one gets
Yeah, but
inside
then
one.
what's a black hole? Is that itself? I mean as you know from my book, I question the underpinnings of the very notion of what we're seeing as a black hole and what we've defined as a black hole. I'm not sold or persuaded that that's even a thing.
That would be another one.
Or dark matter as well. I'm not persuaded that the thing we call dark matter is what we're told it is. There's a whole variety of things like that, or dark energy as well. I'm just not.
I too am very critical of science. Like, okay, just to add one more cherry on top. For example, we don't have any lab until 2018. I think that they finally had one. We don't have any. So as a scientist, you have to go to the like in Switzerland, it's the SNF, and then you get funds if your proposal gets vetted through. There is no one doing research purposefully on faster than light travel. There is not a single scientist doing that. And if you don't have people researching that, and how on earth do you expect to have this thing, which is, I guess, one of the biggest doors for humanity. But yeah, so I think we can slowly close it off if you don't have anything else. It's been a hell of a lot of fun. Thank you for your time. That was really something. I was not expecting it to be that good. And it was very agreeable, very nice. Yeah, I mean, you're an awesome person to debate, I guess.
I get it. I think we'll just call this a chat. Well,
to chat with.
And you're a very fun chat partner too. I appreciated this. Okay. All right,
awesome.
Man. Take care.
Any other remarks? Anything else you want me to put up in the description?
Oh, just maybe a link to my book.
Awesome.
That's good. Yeah.
Definitely. All right, you guys can get Matthew's book on his site. He also has it in a PDF form. Thank you, Matt, again. Have a lovely, I guess it's evening for you? Afternoon?
Afternoon for me, evening for you. All right, take care.
Good night.